Hello, everybody. I'd like to welcome you all today to EarthShift Global's July webinar with Lina Cowen and Teja Chatty. Lina Cowen is a mechanical engineering and sustainable design tech lead at Synapse Product Development, where she helps bring innovative ideas to life. While at Synapse, she's been part of the team crafting Synapse's sustainable product design practice, specializing in lifecycle assessment, sustainable design and implementation, supply chain management, circular design, and whole system mapping. During her tenure, she's had the pleasure of working on a wide range of projects, from small consumer electronics and agricultural technologies to at-home composting solutions and ecosystems for last-mile delivery. Teja Chatty just graduated from the Thayer School of Engineering at Dartmouth with a PhD in Sustainable Product Design and Manufacturing. Her research focuses on developing tools to support industry practitioners in applying sustainable design strategies and lifecycle assessment in the early stages of product development. Her team of students at Dartmouth collaborated with Synapse and EarthShift Global to design and develop a new tool focused on product design. She'll soon start working at Synapse Product Development and Capgemini in Invent as a managing consultant of sustainability. Welcome to you both. Take it away.
Thanks, Holly. Hi, everyone. Teja and I are excited to be here today to talk about sustainable by design and the process that we work on to help our products be more sustainable. So thanks all for being here. Teja, I'll let you start.
Thank you, Lina. Excited to be here as well. All right. I'm going to start off with a definition of sustainable design just to help all of us make sure we're all on the same page. It's not a perfect definition, but it gives a concise summary of what we try to achieve in sustainable product development. We seek to maximize environmental, social, and economic benefits while ensuring that we minimize negative impacts and costs. Ideally, all your products will have positive impacts, but it's hard to achieve that in real life, given all the different trade-offs associated with cost and regulations and engineering performance and several other trade-offs that you might encounter. And it's important to think not just about the environmental impacts, but also about the social impacts and the economic costs of the products that we design. So this presentation, while it mostly focuses on environmental sustainability, will keep an eye to the social impacts as well. Next slide, please. Why is sustainability relevant? This is a question that is a lot easier answered today than maybe a few decades ago, when sustainability professionals like myself had to fight to prove why it was relevant. We're experiencing climate change in real time with various kinds of anomalies in our weather to climate disasters that have affected millions of people. And that has pushed regulations as well as built more consumer pressure on companies to consider their impacts on the environment. And while it is true that regulations tend to lag behind innovation, through sustainable product design, I think we can take a more proactive approach to incorporate environmental sustainability and social sustainability into our thinking. Another key aspect I want to touch upon is resource scarcity. I think as we start to, a lot of our products these days have batteries and electronic components, and you may have witnessed during COVID, a lot of supply chains were broken because they couldn't access the materials that they needed. There is a decline in critical materials like cobalt and so on in various supply chains. So a lot of these problems are interconnected and makes sustainability more relevant in practice. Next slide. Thank you. When do you need to consider sustainability? The earlier, the better, because the earlier you are in the product development process, the more opportunities there are to make big changes, ensuring to limit the negative impacts that your product and its system has on the world. It also allows you to have conversations about the business model surrounding how this product is disseminated into the world and how those big picture business model changes can potentially have bigger reductions in environmental impacts, like think product service systems, for instance, where fewer products are used and shared by more people. As you move along through the product design process and more components and details get locked in, you can start to think about the detailed design aspects, the specific components you use, as well as where you manufacture them and what kinds of suppliers you pick, their social policies, their environmental impact, and so on. All right, next slide. Here's a graphic of the Synapse product development process, as well as how sustainable design considerations can be iteratively incorporated into this process. I think one of the key takeaways here is that it's important to start early and iteratively consider sustainability throughout the process, because it's often the case that earlier on in product development, there are a lot more uncertainties to deal with. There's fewer information about the product itself, and these details get locked in as you move further along. So when you're making decisions, it's useful to track progress along the way. And using, you see the word measure. What we try to do is use life cycle assessment potentially in a more simplified fashion than, say, EarthShift uses. But using life cycle assessment to measure the environmental impacts and using that data to inform design choices is a critical part of the process. I'll hand it over to Lina.
Yeah, thank you, Teja. So as Teja just mentioned earlier, that we incorporate sustainability into product design, the bigger the impact we can have. So this is, as early as the discovery phase. So that's when clients will come to us and they know what problem they're trying to solve, but the design and business model is yet to be constrained. So this, as I said, is the biggest opportunity to make strategic decisions for sustainability. One of the first things we like to do during this phase is make sure we understand what sustainability priorities are most important to our stakeholders and to our business. And we actually do this by graphing different sustainability priorities relative to those two factors. And so you can see an example of that in the top right of this slide here, where we're graphing those different priorities. So the ones that fall in the top right corner should be the focus area for our design efforts, since those are, as I said, most important to the stakeholder and most important to the business. This will vary greatly depending on the type of product we're working on. For example, if we're working on a coffee maker versus a car, those priorities are likely very different. And another thing that we can do with these priorities is actually distill that down into product level goals and requirements. So for example, a lot of our clients will come to us with carbon emission targets or carbon neutrality goals by a certain year. And so oftentimes we'll see that climate change is one of the most important sustainability priorities for those companies. And so having that in mind, we can then distill that into product goals and then a specific carbon budget for the product that we're working on. So a requirement in terms of carbon emissions. This is really helpful because that allows engineers to design to a specific requirement and then measure against that, just like we design to any other product requirement like durability or some other mechanical requirement. So after we have established our priorities, goals, and requirements, one tool that we like to use early in this discovery phase is whole system mapping. And so that's that bottom image on the slide here. It's basically a visual way of understanding the entire ecosystem of the problem we're trying to solve or the product we're trying to develop. In this example, we show material flows with those arrows, and it allows us to see at a system level how well our ecosystem aligns with our priorities. So for example, if waste to landfill is the sustainability priority that our stakeholders care most about, we can look for ways in this whole system map to reduce the amount of waste going to landfill and instead look for opportunities to reuse modules, design our product to be repairable or recyclable. In a whole system map, you can also show data and material flows. And so that can be really helpful in thinking about alternative business models. So for example, if waste to landfill is our priority and we're looking for ways to incentivize our users to return certain modules or products at the end of the useful life to them, showing material and data can allow us to understand whether or not we need to incentivize our users and make sure that they fall into this ecosystem. Okay, so after we've established our ecosystem for our product, we can get into the more detailed design portion of it. And this is what Teja was referring to when she talked about those early stage life cycle assessments. So what we like to do during this phase is make some designs, measure the impact relative to whatever sustainability requirement we've established, whether that's CO2 or some other impact area. We then use the LCA to identify hotspots in the design or areas that we can look to reduce the impact, and we'll apply certain strategies to reduce that. And we repeat this process throughout the development process of whatever product we're designing. This is really important to do that measurement step because oftentimes our intuition isn't actually what the hotspots of our design might be. For example, a lot of clients will come to us thinking that they need to switch to recycled materials or improve their packaging. But by doing an LCA, we can really clearly show them where we should be focusing our energy to have the greatest impact. It's really important at this stage to think holistically about the solution space. So for example, if a material is the highest impact area, rather than just jumping to using a recycled material, it's important to think about other ways you can approach that. Like, can you increase the life of that particular module, or can you reuse it in a future product? Really thinking about the system as a whole as we look to reduce the impact in whichever impact area we're looking at. Okay, so after we've developed our designs, we've gone through and measured the impact against our requirement, and we've gotten to a good place there. As we work towards manufacturing, it's really important to be thoughtful about the partners we choose as we're actually going through that process. Different manufacturing partners will have very different stances on sustainability, and we see more and more are advertising that they're a sustainable company. But it's really important to push that and try to understand exactly what that means. So it's totally reasonable to ask our manufacturing partners, what type of energy are you using? Is it from renewable sources? Where are you sourcing certain materials? And this is really important because it helps us close the loop on our LCA. Because when we run an LCA, we're using industry average data, and there's some uncertainty in that. So making sure that our assumptions are accurate and we're able to really narrow down on what the actual impact of the product that we're bringing to life is. And this is the case for manufacturing partners, service providers, and our logistic partners, really closing the loop on the entire life cycle. Okay, Teja, I'll pass it back to you.
All right. That was a lot of valuable information there that you covered. But it's important to look at what challenges you might face over the course of incorporating sustainability into your product development process. And like Lina just pointed out, there are often data gaps and uncertainties, especially when you try to apply life cycle assessment in these early formative stages of the product development process. And it's critical to account for that uncertainty in the results, to be mindful of it, and to constantly update your assessments as more and more data becomes available. And recognizing that the databases that you pull this data from often use averages, like Lina pointed out, and trying to fill those gaps by potentially collecting more accurate on-the-ground information from your partners and vendors. Another key aspect is ensuring that you're able to communicate these results with a diverse set of stakeholders. oftentimes it comes down to how you present the information. With environmental impact assessment, often there are terms and there's terminology that everyone might not be familiar with. So finding ways to contextualize that information to be able to convince them that this is important and these impacts are the reason why we're taking certain actions. One useful way to do that is to try to benchmark your results against existing products that your stakeholders might recognize, or comparing various concepts against each other. And finally, working to translate these results into actionable design decisions is often a chasm that this process has to pass. And it comes down to understanding the impacts, where they're coming from, what the sources are, and what is possible to achieve within the limitations of the product development process and all the trade-offs that exist in that context. But all right, I'm gonna pass it back to Lina for the next few slides on case studies.
Great, thanks, Teja. So yeah, now that we've talked about the process, we're just going to walk through a few case studies of actually putting this into use. So for this first case study is of a coffee maker. So this company came to us at Synapse to run an LCA of an existing product that they had in order to understand what the hotspots of their current design was to help inform future iterations of this product. They, kind of similar to other clients, came to us expecting that packaging or plastics was going to be their biggest impact area. So it's kind of a prime example of why actually running an LCA is super valuable in making informed design decisions when it comes to sustainability. So we ran this LCA and we actually found that the use phase was the biggest impact area of this product, which, you know, now looking at it probably makes sense to most of you. This use phase incorporated a few different times, I guess. Part of that use phase was the portion of energy in order to brew the coffee. And then part of the use phase was the energy to actually keep the coffee warm after it had been brewed. So after running this LCA, the use phase obviously was our focus area for design improvements. And we focused specifically on that keep warm function, since that wasn't actually necessary in order to create coffee, which was the output product of this device. So there's a few ways that you can, you know, keep coffee warm. They could use a better insulated carafe so that they don't actually need that hot plate. They could have users opt in to the keep warm function. And, you know, obviously these have impacts to the user and the actual experience that they would have with this device. So, you know, considering other requirements for the product, we ended up recommending a smarter keep warm function. And by implementing that, they could actually reduce the energy used during the use phase by about 20%. This next case study was for a personal care device. And unfortunately, we can't talk too specifically about this product, and it's just a generic photo for client confidentiality. But this product consisted of two portions. There was the reusable portion, and then there was also a consumable. And throughout the life of the product, 200 consumables would be used by the user. And so our client had pretty stringent requirements on pretty stringent drop requirements and cosmetic requirements. So they ended up having this really bulky plastic consumable in order to meet those mechanical requirements. And so in running an LCA, we actually found that the consumable was the biggest impact area of this product, just because it was so over designed for what it needed to be in order to meet the other product requirements. And so this obviously became the focus area for design improvements. And our client was actually able to reduce the consumable carbon emissions by about 70% by changing the consumable to have a reusable portion, which was still able to meet the drop in cosmetic requirements. It was like this plastic shell. And then they split out the reuse or the consumable with this like cardboard sheath piece that they would insert into that reusable portion of the consumable. So by splitting it and having that high impact material be reused and instead simplifying the consumable to that cardboard portion, they were able to reduce the carbon emissions of that portion of the device by about 70%. So that was pretty significant. And then lastly, this case study was for a client called Mill, and Mill created a at-home composting device. So this at-home composting device, you would put in your food scraps, and it turns it into this pre-compost material. So it heats up the food, it grinds it down, and then it kind of is in this state of a pre-compost material. And this is a environmentally friendly company, and obviously they're trying to be very climate conscious. And so they wanted to make sure that in developing this product, they had a net positive impact on the environment. So obviously by introducing this device, they are reducing the amount of food waste that goes to landfill that will ultimately release methane. But they also were using this pre-compost mix as chicken feed. So what they would do is they would collect this mix from folks' homes and use that as chicken feed so that there was less land used to grow chicken feed. So there's kind of two benefits of this product. It's less food waste and less land dedicated to growing that. And so, in developing this product, they wanted to make sure, as I said, that there was a net positive on the environment. So we looked specifically at the materials and manufacturing impact of this product. And they did indeed have a positive impact. It's actually a really interesting case study. So feel free to go online to their website to read more about it. But again, to Teja's point, like this was done during design, and they wanted to do it during design to make sure that they didn't get all the way to manufacturing to find out that, no, the energy used for this device actually would cause it not to have a net positive impact on the environment. Cool. And those are our case studies. Teja, I'll hand it back to you.
Awesome. All right. So in summary, I want to go through some takeaways from the presentation. First, you want to start early and consider sustainability throughout the product development process. And it's important to think holistically about the system surrounding your product and to expand your scope from focusing just on, say, materials or manufacturing to think about the overall life of the product and the various stages that it goes through the course of its life. And the use of simplified LCA in this case throughout the process allows you to validate your decision making with real data, and that's critical both to make better decisions as well as to be able to convince your clients and partners of where the environmental impacts lie and why those decisions are being made. All right, so we can open it up to questions. And in the next slide, you'll see our emails. So feel free to reach out even after this presentation if you have any questions.
Thank you both, Teja and Lina. And right now we will have Brighton Moeller take your questions and give them for their answers. Thank you.
As Holly said, thank you both very much. This was a really interesting presentation, and I appreciated hearing the kind of the Synapse way of handling this. One question from the audience is, do you include a supply chain representative in your initial LCAs? They mentioned that for many companies, early design is an engineering only stage.
Yeah, we don't typically include a supply chain rep in our early LCAs. We are using it more as a design tool. And we don't necessarily know, where manufacturing might occur. And there's a lot of unknowns when it comes to our supply chain at that point. So we are typically using industry average data until we get further along in development and can start filling in those gaps.
Mm-hmm. That makes sense. We also have a question that's pretty broad, so I think answer it the way that you would like to, but how do you define sustainable materials?
That's a tricky question for sure. But I think one way to think about it is in comparison to an alternative. So oftentimes, depending on what the context is and what type of materials you want to use, say plastics, right? You would look at the various options that are available to you that maybe suit the engineering requirements, and then consider what the environmental impacts might be across, say, those different alternatives, and potentially go for the best alternative sustainability wise. But it's often the case that there are many other trade-offs to consider. But it's, I would say, in comparison to something else, is easier to think about when picking a sustainable material. What do you think, Lina?
Yeah, that's a great question. There's always like best, better, and good materials, I guess. Like there's definitely different tiers of sustainable materials that we're seeing. And so I think, yeah, to Teja's point, like trying to choose better materials is kind of where we're at this point. When it comes to sustainable design. So oftentimes we're, comparing the carbon footprint or other impact areas of different materials to make those more informed decisions. But yeah, that's a good question on like what an actual definition of a sustainable material. Maybe one that's like regenerative or something would really truly be a sustainable material.
Thank you. I think that you could probably think about that question for a long time. We all probably could. How do clients typically react when you're presenting these LCA results?
I think oftentimes they're a little shocked, and maybe, I don't know, in some cases, like you'll see them be like a little defensive about how they got to a certain state, or trying to rationalize why that can't be changed, like something can't be changed. So yeah, kind of two camps of like, oh, this is really interesting, great information, we'll take it back to our design team. And then some folks are like, oh, like we can't change that. But I think, as they mull on it longer, they'll find that there are ways to make improvements, even if it's not evident like initially. So yeah, in general, it's been pretty positive, and you definitely have to approach it in a mindset that understands like how they got to this point and trying to work together with them to find better solutions.
Yeah, thank you. We have a couple of questions here about simplified LCA versus full LCA. So you mentioned that you're doing simplified LCAs in order to inform some of your design decision making. One person would really like you to elaborate on what that means to do a simplified LCA, and whether you're also doing full LCAs sometimes for these projects, or does simplified give you everything you need?
That's a great question. And the thing is, when you think about performing a life cycle assessment, there's a whole spectrum of how much detail and depth you can go into. And professionals like those at EarthShift Global, when performing, say, ISO certified life cycle assessments, would need to go into a lot more depth than, say, the details that are available to you during product design. And oftentimes, your choice of life cycle assessment tools also affects how much detail and how much detail you can consider in your assessment. There are more simplified calculators that you can use, like Sustainable Minds or Equalizer, or several other such more simplified tools. And then there are the more industry standard tools like SEMA Pro that have a lot more data, that have a lot more features to be able to dig deeper into your assessments. I hope that gives you a sense for it. I think earlier on in product design, the challenge is you don't always have, there's a lot of uncertainty, and you don't have all the data you need to be able to do an in-depth assessment. Oftentimes at the end of the product development process, once all decisions are made and more data is locked in, companies will opt to do a full LCA, potentially get it certified to be able to make public claims about the environmental benefits of their products and so on. But yeah, hopefully that helps.
Yeah.
Yeah, just to add to Teja, I think, to her point, there's different tools we can use. There's uncertainty we need to account for. But even, with that uncertainty, you can find hotspots in design and you can design to reduce those hotspots. So oftentimes, like, the biggest impact area is the biggest impact area by such a high, percentage that even though there is uncertainty in the design, it still helps us design teams focus on ways to improve the design from an environmental standpoint.
Right. And time is often a key consideration too. And in product development, there's so many different factors to consider. You're probably on a fast-paced timeline. You might not have the same luxury of time to do all of the in-depth data collection early on.
Yeah, that makes sense. Another question we have from the audience is, how do you think about material performance when you're thinking about material sustainability and selection?
Yeah, that's a great question. I think, those are some of the hard trade-offs we have to make during design. We have a list of requirements, mechanical requirements, sustainability requirements, cost requirements, and it really is a, balancing act to achieve something that can meet all of those requirements. So you might have to make trade-offs, and I think what's important is to really push on any requirements that might seem like over-defined or over-constringent. Really understanding the use case of the product and questioning why you've gotten to certain points on requirements can maybe help open up that space a little bit to allow for materials that might not meet the same performance, but can meet the same level in the product, and it's not actually required. A lot of times we'll have to do decision matrices, and you have your different requirements that you're grading against. So whether it's sustainability and drop performance or whatever else, which can help you make those final decisions. But and honestly, they're coming out with better materials that oftentimes have very similar mechanical performance to less sustainable options. So definitely material science is advancing in such a way that hopefully we don't have to make those trade-offs as much.
Thank you. Another question I think maybe related to that is, in your opinion, what are the sustainability attributes that can make a product stand out over others or be the next best alternative?
I'm really excited about circularity, and I think products that are designed to be more circular stand out to me. So, there's companies like Fairphone, or there's a laptop company too, and I'm blanking on their name right now. But basically, these companies that have designed their products to be completely modular and repairable at home, I think those are really exciting to me, because by designing a product to be modular and repairable, you're also designing it to be upgradable. So oftentimes, companies come to us and they want a product to last a certain amount of years because they know that in 5 years, this new technology is going to come out. But if you design your product to be modular, you can design it so that you can upgrade it once that new technology comes out and it still is relevant in the market. So those are the types of products that really stick out to me today. Teja, I don't know if you want to add anything there.
No, I think I agree. I think watching these big business model changes that expand the scope beyond just individual product attributes, I think really change the way we think about sustainable design and broaden the scope of what we can do. Another thing that excites me, I think, with Fairphone is a key consideration in their supply chain is ensuring that all their workers are paid fair wages and routinely auditing their suppliers to make sure that they have fair social policies. It expands the scope beyond just environmental sustainability to think about the social impact of your business. So that's exciting to me as well.
Yeah, absolutely. One question that just came in here is, we're finding that designing for sustainability can be more costly, but consumers don't want to pay for it or don't always want to pay for it. And this person's wondering, how are companies dealing with that issue? So I think it's about when maybe a company's goals are not fully aligned with the consumer's wallets.
Yeah, that's interesting. And, you know, I think that's often the belief is that something more sustainable is going to cost more. But like what we like to say at Synapse is that's not necessarily the case. You know, oftentimes by removing components or simplifying the design, we can be more sustainable and reduce cost. But there certainly are cases where it will cost more. And I think, you know, I feel like I've seen all these reports lately about consumers being willing to pay more for a more sustainable product. So I think, you know, consumers are heading in that direction. And I also think that the cost of more sustainable materials and options will actually, there will be this interesting crossing point where, you know, those materials are actually going to be lower cost than their virgin counterpart, just with, you know, the fact that it's getting harder and harder to mine for some of these materials. So yeah, hopefully we'll see that kind of transition point in the next decade or so. And in the meantime, I think consumers might be willing to pay a little bit more, but I don't know, it might be a personal thing for some folks and availability of doing that. Anything you want to add to that, Teja?
Yeah, I guess one thought that came to mind as you were answering that question is, in some ways for companies, it is a way to plan for the future as we see more and more regulations start to limit what you can do. I think one example that really sticks out to me is EPR regulations, so extended producer responsibility regulations, where companies are being held accountable for the end of life of their products and having to pay to ensure that they're properly recycled or remanufactured and so on. And in a way, it is preparing for these future costs, and potentially incorporating circular supply chains can mitigate the costs associated with complying with regulations like this that come down the pipe.
Thank you. One participant would like to know if you can explain the difference between LCA and EIA. I must say this is a new acronym for me.
Yeah, I'm a lot more familiar with life cycle assessment and the application of LCAs to products, but from what I vaguely remember reading about environmental impact assessment is it's often referred to in a more public goods context. So like looking at large projects like, say, building a park or something that might happen in the future, policies that might be implemented in the future, and looking at what the impacts associated with that are. But I'm not 100% familiar with EIA as I am with LCA.
Alrighty. I think that's probably look-upable, fortunately. Do you see room or interest from your clients in using optimization or other computational design methods?
Yeah, maybe. You know, we sometimes will, this isn't necessarily a computational design method, but sometimes we'll put together like Excel spreadsheets for our clients where they can like toggle on and off different design changes that they might make from a sustainability standpoint. And so they can see, you know, the impact to carbon emissions if they do these factors, but not these design updates or whatever it is. But yeah, certainly there probably are some good tools out there to help manage trade-offs when it comes to sustainability. I'm not, I guess, not familiar with which is the best for that, but certainly open to learning more about that.
Another participant was wondering if you have special comments or considerations on consumables and packaging. I know you spoke a little bit about one product that had an impactful consumable and touched on packaging, but I think they were particularly curious about kind of the difference in considerations, if I'm interpreting this question right, the difference in considerations between thinking about a consumable or packaging heavy product versus something where it's more about like a device that's not consumable?
Yeah. One thing that comes to mind immediately with packaging is just trying to use single materials. So, and making it really clear to the user on what they're supposed to do with the packaging once they're done with it. One of my colleagues was really adamant about good labeling, and I think, that can actually make a really big difference. Labeling, single materials, so they're not having to separate, and then using low impact materials or trying to reduce the amount of material you're using for packaging. I think there's been some creative new materials and like new ways to package things recently. So I'm excited to see the progress in that area. Teja, anything you want to add to packaging?
No, I think that covers everything. I'm not super familiar with packaging sustainability.
So something I'm really curious about is how you handle uncertainty. How much uncertainty are you accounting for, or how do you decide how much uncertainty to account for when you're doing LCAs during the design process, and what the biggest sources of that tend to be?
That's a tricky question for sure, because I think there are many ways to account for uncertainty, and more concrete ways and somewhat more simplified ways of considering uncertainty. I think a big source of uncertainty is often when you haven't made a decision on exactly what type of material, for example, to use, and you are considering a number of different choices that might meet your other requirements, but from a sustainability standpoint have not picked one. Feature, remember, we worked on for a little bit in designing an LCA tool was considering grouping these materials into a bucket and incorporating this whole group of materials into the assessment, and looking at where the biggest impacts come from among all of these alternatives and what the differences are. So that could be a potential source for uncertainty and a way to address it. Lina, I'm curious if you had any thoughts on it and how you consider it in some of your assessments.
Yeah, I think the sources of uncertainty kind of changes throughout the product development process. So, early on, there's probably uncertainty in the design, like you might be looking at two different materials for a specific component, or the design isn't fully developed at that point. So at that point, design uncertainty kind of is dominating. And then as you move towards manufacture, and then kind of in the middle of the phase where your design is more locked, there's probably uncertainty in the data. So you're using, industry average data that might not fully align with manufacturing. But then as you get further along and work with your manufacturing partners, hopefully that goes down. So yeah, definitely the amount of uncertainty hopefully goes down throughout your development process, but it can be pretty large early in the process.
Then another question we have here is about recommendations for an in-between tool. So you all mentioned Sustainable Minds and a couple of other really more beginner tools, and SEMA Pro and Gabby as the industry standard advanced practitioner tools. And they were sort of wondering what might be in between. I think this is a moment for a small pitch or mention of the tool that that Synapse, EarthShift Global, and EarthShift Global have been developing along with Teja and her colleagues at Dartmouth, which is forthcoming in the next year or so, hopefully on the sooner end of that, and will occupy probably that middle level. So keep your eyes peeled for that release. But as far as right now, do you have any recommendations for what people should use?
I think one thing I can think of is there are a lot of industry-specific tools that are coming up depending on what industry you're in. I know the Higg Index folks have some tools, especially if you work in the textile space or the apparel space, to be able to quickly quantify environmental impacts. And it's a bit more rigorous than the options you might find on sustainable mines. Similarly, there are tools in the construction space and building sustainability space that are definitely more rigorous than some of the entry-level tools. So I'm seeing a lot of industry-specific tools come out, but I'm excited for the tool that we all collaborated on to come out as well in the next year or so. That will be more of a generic tool for folks wanting to use LCA.
Thank you. So I'm going to just ask one more question, and then I think we can close out. What is one of the biggest takeaways you'd like folks to walk away from today?
Teja mentioned it in the last slide, but starting early, I think that, designing sustainability into a product or ecosystem, it gets harder and harder as you get further along the development path. So really starting early and making it a priority from the initial, problem solving stage can have a huge impact on your product. And making, for example, making a product circular, like that has to be decided on really early on to make it modular and develop that entire ecosystem for that product. So that's the one takeaway I hope that everyone walks away with. LCAs are often a tool that's used at the end of development, but it can be, understanding the product early on can have a huge impact.
No, that's a great takeaway. I think we should leave folks with that. Thank you.
Oh, and thank you all. It's been a great presentation, and hopefully we've given a lot of food for thought for folks. So thanks again, and bye, everybody.